Cisco wireless architecture. In this video, we will learn about the different approaches or architectures that allow access points to be networked together for an enterprise. We will learn also how some architectures are more scalable than others and how to manage each type of wireless network architecture. We can build the Cisco wireless network according to several different architectures that are described in this video that follow. As you work through this video, think about how each architecture can be applied to specific environments, how easy it would be to manage and deploy and troubleshoot the network, how the access points can be controlled, and how data would move through the network. First, let me to explain about the distributed architecture. An access point's primary function is to bridge wireless data from the air to a normal wired network. An access point can accept connections from a number of wireless clients so that they become members of the LAN, as if the same client were using wired connections. Access points acts as the central point of access, hence the AP name, controlling client access to the wireless LAN. An autonomous AP is self-contained. It is equipped with both wired and wireless hardware so that wireless client associations can be terminated onto a wired connection locally at the AP. The APs and their data connections must be distributed across the coverage area and across the network. They can be managed in an autonomous fashion or through a cloud-based mechanisms. Let me to explain about the autonomous AP first. Actually, distributed architecture can be implemented in two forms, autonomous architecture and also cloud-based architecture. First, about the autonomous architecture. About the autonomous APs, we can say they are self-contained, each offering one or more fully functional standalone basic service set or BSS. They are also a natural extension of a switched network, connecting wireless service set identifier or SSIDs to wired virtual LANs or VLANs at the access layer. This figure shows the basic architecture, even though only 4 APs, as you can see, or 4 autonomous APs are shown. A typical enterprise network could consist of hundreds or thousands of autonomous APs. As you can see, we have autonomous APs connected to access layer switch and then distribution layer and finally core layer. Actually, the autonomous AP extends our LAN to wireless clients. What exactly does an autonomous AP need to become a part of the network? Refer to this figure, which focuses on just one AP and its connections. The wireless network consists of two SSIDs, WLAN 100 and WLAN 200. As you can see here, we have two SSID. Actually, these correspond to wired VLANs 100 and 200 respectively. The VLANs must be trunked from the distribution layer switch, where routing commonly takes place, to the access layer, where they are extended further over a trunk link to the AP. Actually, each wireless client connects to the or associate with to the SSID WLAN 100, needs to send its traffic in VLAN 100, and each wireless client that connects to the SSID WLAN 200 should send its traffic with the tag of the 200 actually for in this trunk link. This is the responsibility of the access points. Actually, if the user or wireless client is member of WLAN 100, the access point should send its traffic with the tag 100, and if the wireless client is a member of WLAN 200, the access point should send its traffic with the tag of 200. Because of that, here between the access layer switch and also for example the access point, we should have a trunk link. Why? Because we are advertising different SSIDs and we need to map each SSID to one unique VLAN, and here we need trunk link and after that, with the tagging of those traffic received from the wireless clients, we can differentiate for example each SSID with different VLAN tags. Also here, as you can see, on the distribution layer switch,